Today we have discussed the function fx which is equals to x if x is in rational number, and if x is in irrational numbers, then this value is function's value is minus of x. When we have to prove that this function is continuous only at x equals to 0, otherwise not any value of x is equals to 1, x equals to 2 and x equals to 2 and so on, there exists no continuation of the function with any values of x. But when the x is in rational number, then the function's value gives x, and when x is not is in rational number, that is in irrational number, then the function's value gives minus of x. This is we have to learn. Okay, now let us start. If x be any real number for all n is in n, then there exists a rational number and irrational number. Let an is in rational number and bn is an irrational number. Then by accumulating property, x minus 1 over n, x plus 1 over 1, between two real number there exists a rational number, between two real number there exists a irrational number, right? So this implies that mod of an minus x is less than to 1 upon n, and mod of bn minus x which is less than to 1 over n, right? Taking limit of this n tending to infinity, this gives an is equals to x. The limit of an is x and limit of bn is also x, so both are equal. If f is continuous at x by the definition of continuity, then f of an is equals to f of x and f of bn which is equals to also f of x, because the limit of both are equal. But we know that the value of f an, if an is a rational number, if x is in rational number, then it is x, and x is in irrational number, then it is minus of x. So this gives that f of my an, limit n tending to an which is equals to an, and f if limit n tending to infinity minus of bn, because of bn is in irrational number. So function's value differ from this. So then function's value x is equals to fx is equals to minus of x. This gives x is equals to minus of x, 2x is equals to 0 and x equals to 0. So the point x equals to 0 is the only point where the function is continuous.